Welcome back to the deep dive and to Chapter 6 of our big 10-part series on scaling digital capital. We've uh, we've really been building this thing from the ground up.
We really have. So if you've been following along, you've got the foundation, you have the data substrate, which is, the floor where all the knowledge lives.
And we have the workers,
Yep.
the synthetic developer and the researcher agents.
Right. But we're at this critical point now. You have all these amazing parts, but they're not talking to each other.
Which brings us to today's mission. Chapter 6, the nervous system. This is all about the complex wiring that makes the whole thing come alive and act like one unified body.
Not just a collection of smart, isolated parts.
Exactly. And we have to start this with the problem this chapter is trying to solve. It's really frustrating what he calls the tool zoo.
Yeah, the tool zoo. It's that moment you realize your super intelligent, expensive tools are actually creating more friction, not less.
Right. So imagine you've done everything right. You've got a top-tier coding agent, a fantastic research agent, and a customer support chatbot. They all work great on their own.
In isolation, they're brilliant.
But that's the problem. 3 tools, 3 separate interfaces, 3 logins. It's 3 silos. And none of them have any idea the others even exist.
So the research agent is out there, scanning security blogs, and it finds a major vulnerability, something that directly impacts your code.
What does it do?
Nothing. Well, not nothing. It writes a perfect report and files it away. It just doesn't tell the developer agent to actually build the patch.
Or another one. The support chatbot starts seeing a pattern. A new bug is making users furious.
It logs every single interaction flawlessly, but it never flags engineering. It never creates that high-priority ticket.
And here's the one that's just the most maddening. The developer, eventually told by a human, builds the fix.
Yeah.
Pushes the update. Closes the ticket.
But the chatbot, because it isn't in that loop,
It just keeps giving the old, wrong, now totally obsolete advice to customers.
you don't have a system. You have a collection of isolated capabilities. And the insight from the book is just brutal here. The whole is actually less than the sum of its parts. It's a total waste of potential.
So this is the orchestration imperative. The nervous system is what turns that tool zoo into coordinated capacity.
It's the wiring. It's the plumbing, the stuff that carries signals and moves information between all those agents you've built.
So practically, what does orchestration really look like?
It looks like seamless handoffs. That's the whole game. You're enabling synthetic workers to pass work to each other without a human having to step in every single time.
So the research agent finishes its analysis.
And that automatically triggers a work task for the developer agent. It's formatted correctly, it has all the context, and the developer can just start building.
And that is a total shift in the human's role, right? I'm no longer the person who has to notice that report, copy the key findings, paste them into a Jira ticket, and then ping the developer.
Precisely. Without orchestration, you are the router. Every single step is a person noticing, copying, pasting, and triggering. With it, the human effort shifts completely from routing information
To overseeing outcomes.
That's it. Your job is elevated. You're looking at the strategic health of the workflow, not the tiny movements of data.
That makes a ton of sense.
Yeah.
So let's get into the architecture. The book breaks the nervous system down into 3 core components.
Yep. You can think of it as what goes in, what happens to it, and how it all connects.
Okay, so the first one is data input and processing.
This is what fuels the entire system. It's the part that's responsible for grabbing all these different input-structured data from databases, unstructured text from documents, signals from other systems.
And making it all standardized so the agents can actually use it. Because if the data goes in messy, the whole workflow is just going to be garbage.
Garbage in, garbage out.
Yeah.
Or in this case, garbage in, garbage routed very efficiently.
Right, okay, so component 2 is the decision logic. Now, this is the intelligence layer inside the nervous system itself. And it's important to distinguish this from the work the agents do. This is more like the traffic cop.
I can see how that could be confusing. So this isn't where the developer agent writes code.
No, this is where the system decides which developer, maybe a synthetic one, maybe a human, needs to even see that request.
Yeah.
It's applying rules, classifying tickets, routing queries. It's operational intelligence.
And the third piece, integration, feels vital because it's how all this new stuff plays with our old stuff.
Yes, and this is a huge point. The nervous system doesn't replace your CRM or your code repo. It connects them. It acts like this universal connective tissue.
So when the developer agent pushes a fix,
The signal instantly goes to your old ticketing system to close the issue, and to the knowledge base to update the FAQ, and to the support chatbot to refresh its answers.
okay, the wiring is in place. But now we have to talk about governance. Risk. The book has this line: high-stakes situations cannot pass without direct human oversight and critical judgment. This is human in the loop, HITL. And this is where we get into operational reality. For so many industries, full autonomy is it's a massive liability if something goes wrong. This isn't about being cautious for caution's sake. It's an architectural requirement.
Let's use some of those examples from the book because they really ground it.
For sure. Think about financial services. If your system is processing loan applications and it misclassifies the risk on a mortgage, that's not just a bad business decision. That's a huge compliance violation.
Or healthcare. An automated system misreads a scan or misdiagnoses something.
The consequence is patient safety. It's that serious. Same with legal realm. A bad contract analysis could expose a firm to millions in liability.
So HITL becomes this pattern for concentrating our best human experts right where the stakes are highest.
Yes, but here is the big transformative idea that changes everything about governance. Oversight becomes data for learning, not a permanent bottleneck.
Okay, but how? If my experts are already swamped, how do I stop this from just being one more approval queue that grinds everything to a halt?
The key is how you capture the review. Every single time a human expert overrides an AI decision, you have to capture not just the change, but the reasoning.
So it's not just change this.
No, it's, I'm changing this from high risk to medium risk because of this specific clause I found on page 32. That reasoning, that's pure training data for the next version of the model.
So the human work isn't just an expense, it's an investment in making the system smarter. Last quarter's corrections literally become this quarter's accuracy.
Absolutely, and you get this perfect audit trail as a byproduct. You can build decision dashboards that show regulators and stakeholders exactly how a decision was made, what data was used, and where a human intervened. It builds trust.
Okay, so to manage all this, we need a structure. And that brings us to the decision tier framework. This is about matching the level of human involvement to the level of risk.
Exactly. It starts at Tier 1. Low-risk AI decides autonomously.
These are the high-volume routine things where an error is annoying, but not catastrophic.
Right. Think about email categorization, scheduling meetings, basic data validation. If an email gets routed to the wrong folder, it's not the end of the world, so the AI just decides no human review needed.
Then we move up the ladder to Tier 2. Medium risk AI decides. Flags for review.
So these are decisions that are consequential. An error actually matters, but the AI is probably right most of the time, and you still need speed.
What's a good example of that jump in consequence?
Well, drafting a routine customer response that's going to be sent out, or maybe proposing some content for an internal newsletter. An error there could, damage your reputation or just cause confusion.
So the AI decides and it acts, but it also raises a little flag.
Yep. It flags it for a human to spot check later. You're trusting the system, but you're verifying that trust by sampling the work.
And that leads to the highest level, Tier 3. High-risk AI recommends, human decides.
These are the non-negotiables. The stakes are simply too high for full automation.
So financial decisions, hiring recommendations, major customer escalations.
Exactly. Here, the synthetic workforce does all the heavy lifting. It does the analysis, it surfaces the options, it makes the recommendation. But the final call, that's made by a human who signs off on the risk. The AI accelerates, it doesn't replace.
And there's a safety net under all of this.
Yeah.
The confidence threshold.
The uncertainty trigger. It's simple. If the AI's confidence in its own decision is low, if it's not sure, it automatically routes to a human. Doesn't matter what tier it is. If the machine is hedging, a person needs to look at it.
So we have the governance, but we need the technical rigor to back it up. We talked about handoffs, but the book says every single handoff needs an explicit contract. Why is that so critical?
Because without a contract, agents make assumptions. And assumptions are how bugs are born. It's the root of so many failures.
Like the research agent outputs a beautiful summary, but the developer agent was expecting structured data.
And the whole workflow just breaks, probably silently. So you need what he calls a handover contract with 5 really specific parts.
Okay, let's break them down. The first 2 seem to be about the interface. You have to define what the step receives, the exact input format, and what it produces, the exact output format.
Then component 3 is success criteria. And this has to be more than just it ran. It has to be a specific condition. For code, maybe it's passed 100% of unit tests. For research, returned 3 sources with a confidence score over 0.8.
And number 4 is error handling. This feels so important. You have to define what happens when it fails. Does it retry? alert a human, escalate.
And the rule is simple. Fail silently is completely unacceptable in this kind of architecture. If you can't see it break, you can't trust it.
And the last one, number 5, is the human touch point, the circuit breaker.
This defines the exact conditions. Low confidence, weird input, maybe 2 failed retries that automatically pull a person into the loop.
So contracts define the handoffs. But if we can't see what's happening, we're flying blind. This brings us to the visibility principle. A workflow without logging is a building without windows.
Observability is just non-negotiable. It's the foundation of trust and debugging. And your system needs 5 key characteristics here.
Okay, first, it has to be transparent. You need real-time visibility. What's running, what's stalled, what step is it on?
Second, debuggable. When something fails, you need the full story. The stack traces, the logs, a snapshot of the state. You need to know exactly what broke and why.
Third, repeatable. Similar inputs have to produce similar results. If you can't reliably recreate an error, you can never really fix it.
Fourth is auditable, which we've talked about. That complete trail of every decision, every handoff, every human touch point for compliance.
And fifth, maybe the most important one of all,
Killable. The shutoff valve is not an optional feature. You absolutely must have the ability to halt any workflow, any agent immediately, per workflow kill switches, per agent circuit breakers. If it goes sideways, you have to be able to stop it instantly.
All that rigor is what allows us to scale trust. And the path from a pilot to full production isn't like flipping a switch. It's a gradual 5-step process.
Step 1. Scope high-impact cases. Don't start with the easy stuff. Start where mistakes have real risk compliance, finance, customer-facing stuff.
Then step 2, pilot and measure. You deploy in a limited way and you just track everything. What's the intervention rate? How often are humans overriding the AI? Get your baselines.
Step 3 is where it gets interesting. Iterate and scale. This is that learning loop. If your data shows that humans confirm the AI's decision 95% of the time, you're reviewing too much.
So you start to back off. You refine the thresholds. Maybe you only sample 25% of the borderline cases instead of all of them.
Then step 4 is to institutionalize governance. You document the roles, define the escalation paths. You turn this experiment into a standard operating procedure.
And finally, step 5, optimize cost. It's a balancing act, right? The cost of having an expert review something versus the potential cost of an AI making a mistake.
Exactly. You're trying to find that sweet spot, that optimal point of supervision that minimizes your total risk and your operational cost.
So, the nervous system. It's really the infrastructure that turns all these powerful but isolated AI toys into a single, coordinated, functioning workforce.
And to recap those core principles, 1. Every single handoff needs a contract. Explicit interfaces are mandatory.
2, decision tiers match your governance to the stakes, low, medium, high risk. And that uncertainty trigger is your safety valve.
And 3, visibility is non-negotiable. The system has to be transparent, debuggable, repeatable, auditable, and above all, killable.
Which brings us to the end of this deep dive, and we spent a good amount of time on that killable component, the big red button, the shutoff valve. So here's the thought to leave you with. Given that the human-in-the-loop process is constantly feeding data back, making the system autonomously smarter and, well, probably more complex over time, what operational processes do you need to guarantee that your emergency kill switch stays accessible, tested, and effective, even when your synthetic workforce evolves far beyond its original design?
Something to really think about. We'll see you next time as we finish up the infrastructure with Chapter 7, the synthetic org chart.